Hello, class. Today we're starting chapter 1, and we're going to be going over rational numbers as decimals here in lesson 1.1. So, as always, we got some definitions for us here. So, a rational number. A rational number is any number that can be written or expressed as a fraction of two integers. So, obviously, things that are rational numbers are fractions themselves, such as 1/2 or 1/5. We can also look at things such as decimals, like, for example, 0.5. The reason 0.5 is a rational number is because we can rewrite this as a fraction here. This could become 5/10. So that is also a rational number. Last but not least, we also have repeating decimals, which would be something like 0.3 repeating, or I don't know, 0.5 repeating. You could go even deeper here. You could do like 0.26 repeating, or we just go 2, 6 on and on forever. So I got a question here for everybody. So why are decimals also considered rational numbers if they are not written as fractions? So think about that one for a second, and hopefully you can come up with the answer on your own. Okay, so for our goal today we are going to be working on locating repeating decimals on a number line. We will use approximations that are slightly above and below our decimal to try and find where to locate it on the number line. We are also going to learn how to convert a repeating decimal to a fraction. Remember, repeating decimals are rational numbers, so they can be written as a fraction. All right, so let's start with locating repeating decimals on a number line. So say, for example, I want to plot the point 0.5 continuing on this number line here. Well, let's start off by labeling this number line a little bit, right? So this would be a 0.1, 0.2, 0.3, all the way up to 0.9 because we're going from 0 to 1 here. Okay, so this would be all of our number line filled in here, going to the nearest 10th decimal place, and we want to graph 0.5 continuing on the number line. Well, it would make sense that 0.5 continuing is slightly larger than 0.5, right? Because while they have the first same number here, this one over here is larger because it keeps having repeating 5s and 5s going on forever. So we would say that this is larger than 0.5 on a number line. And obviously, if we're working on a number line here, 0.5 is right here. Now we can also say that 0.5 continuing would be less than 0.6, right? Because this is the next decimal place up from this one right here. 6 is larger than 5, so 0.6 is larger than 0.5 continuing, regardless of how many 5s are there. So plotting that 0.6, that would be right here on our number line. Now to plot our 0.5 continuing, we'd really just want to find a point in the middle of these two numbers here. So we could just go straight up, do a dot right here, and we could say that this is 0.5 continuing. So how do we plot rational numbers or repeating decimals on a number line? What we got to do is we got to use a number that is both smaller and another number that is larger than our repeating decimal, and you're going to plot the repeating decimal in between those 2 points. The goal is to get as close to your repeating decimal as possible. So clearly I could have chosen 1 and 0 for numbers that were smaller and larger than 0.5. However, since we wanted to get as close as possible to plotting it here, it made more sense to do 0.5, which is directly underneath 0.5 continuing, and 0.6, which is directly above 0.5 continuing. Okay, so that is plotting or approximating a repeating decimal on a number line, but also we can write repeating decimals as a fraction. So we want to let x be equal to 0.26 continuing, where the 6 goes on forever here. So what we can do here is we can choose a letter to equal a number. Remember, guys, this is called choosing a variable. So here, we're going to let x be equal to 0.2666, continuing forever. So that means that whenever we see an x, it's going to be equal to this here number. And this is the same as the one over there. I just wrote less 6s. Okay, so the way we have to convert this into a decimal here, into a fraction here, is by doing a little bit of algebra. So we want to start off by multiplying both sides of our equation by however many repeating spots we have here, or however many decimal spots we have. So here we have 2 decimal spots here, so I want to multiply this by 100 because 100 has 2 zeros. So we're going to multiply the left side of the equation by 100, so we get 100x. and we're going to multiply the right side of the equation by 100. So this would just move the decimal place over 2 spots, and we would get 26.6 repeating. Remember, this was all just filled up with sixes right here, right? So those sixes are still going to be here after we multiply by 100. Okay, so the next thing we want to do is get rid of this repeating decimal here. And the way we're going to do that is we are going to subtract x from both sides. Remember, x was equal to 0.26 repeating, right? So when we subtract x from both sides, we could subtract an x from the left because we have like terms there, and we could subtract the 0.26 repeating from the right side. All right, so it'll help us if we line this up down here. So we got 26.6 repeating minus 0.26. All right, remember, all these sixes here are going on forever. So if we're looking on the right side of the equation, all of these repeating decimals should cancel out. All of those sixes would subtract from each other and they would make 0. So now we no longer have a repeating decimal. Now we just got to do the math here. 26.6 minus 0.2. Okay, so 6 minus 2 is 4. We're going to bring our decimal down here. 6 minus 0 is 6, and 2 minus 0 is 2. So you get 99x is equal to this number right here, 26.4. All right, now we could just divide both sides of our equation here by 99 because we want to solve for x. And we get x is equal to 26.4 over 99. All right, if we want to go into our calculator right here and check this, there you go. We do get 0.26 continuing, which is what our number was originally equal to. If we want to clean this up a little bit so we don't have a decimal in our fraction, we could just multiply the top and bottom of our equation here by 10. So we get 264 over 990. And that would be equivalent to 0.26 repeating as a decimal. So that right there is how you convert a repeating decimal into a decimal. Repeating decimal into a fraction, And the reason that that's important is because that shows that repeating decimals are indeed fractions. No, they are indeed rational numbers. Gosh, I'm getting all my words twisted up right here. We wanted to show that repeating decimals are indeed rational numbers. And we did that by showing you can convert a repeating decimal into a fraction. All right, let's do one more for practice here. So what if our decimal is larger than 1? For example, x is equal to 20909 going on forever here. All right, so we're going to do basically the same here. We're going to have x is equal to 2.09 continuing. So 2.09 continuing. Again, we want to multiply both sides of our equation by how many repeating decimal spots we have in a multiple of 10. So we have 2 repeating decimal spots, so I should multiply this here by 100. So we have 100x is equal to 209.09 repeating. All right, now we can subtract x from both sides. So 100x minus x will be equal to 209.09 repeating minus 2.09 repeating. So again, let's stack these up over here so we can see what's happening. All right, so again, since both of these are repeating here, these are going to cancel themselves out, so we no longer have any decimals. And now we have 209 minus 2, which would be equal to 207. So you get 99x is equal to 207. All right, now we just have to divide both sides of our equation by 99, and we are going to get x is equal to 207 divided by 99 is equal to 2.09 repeating. So we are good there. Our x is equal to 207 over 99. That is 2.09 repeating written as a fraction. So retracing our steps here, the first thing we did is we set a variable equal to our repeating decimal. Then we found out what multiple of 100 we needed to multiply by, or what multiple of 10. Since we had 2 decimal places, we multiplied by 100 because 100 has 2 zeros. Then we subtracted an x from both sides, so that way we could get rid of the repeating decimal. So 100x minus x would be equal to 99x because 100 minus 1 is equal to 99. And that was equal to 207. Then we simply needed to solve for x by dividing by 99 on both sides, and we got x is equal to 207 over 99. Alrighty, everybody. We got some practice problems for you today, so I'd like you guys to, review of our steps here. So just to remember, the first thing we did was to choose x or a variable to be equal to your repeating decimal. Second, we multiplied by a multiple of 10 depending on how many decimal places repeat. Third, we subtracted x from the left and the repeating decimal from the right. Remember, we can do this because they are the same number. Lastly, we solved for x by dividing and then simplify. So I would like you guys to get those steps written down on your notebooks so that way you will be able to practice with them. Speaking of practice, we got 3 practice problems for you here. I would like you guys to try all of these out on your own. Again, these are repeating numbers right here, and we'll do them in class tomorrow as a warm-up. Alrighty, so in conclusion today, we learned about rational numbers. We learned about where to put repeating decimals on a number line. And finally, we learned how to convert a repeating decimal into a fraction. So remember, write 2 complete sentences. We're summarizing what we learned in lesson 1.1. Alrighty, everybody, I'll see you all in class tomorrow. Have a great rest of your day. Bye, everyone.